Okay, this is polar coordinates, section 10.7, part 2. In this video, we'll discuss converting between the systems. And the two systems are rectangular coordinates and polar coordinates. Okay, so first, let's look at polar to rectangular conversion. So you're given a point in polar coordinates, so you know the r and the theta values, and you want to turn that into rectangular coordinates, x comma y. All right, so the basic scenario is, you know this distance is r, and you know this angle is theta, so it's part of a right triangle, and you're picturing turning this into rectangular coordinates. So the polar axis can just be part of the x-axis, and then this will be the y-axis. So basically, the rectangular coordinates, x will be the adjacent side of this triangle, and y will be the opposite side. And so then the SOHCAHTOA definitions apply. The cosine of theta is x over r, adjacent over hypotenuse, and the sine of theta is y over r, opposite over hypotenuse. And if you solve for x and y, because that's what you're looking for, you come up with this. So x will be equal to r times the cosine of theta, and y will be equal to r times the sine of theta. Always true. Doesn't matter if r or theta is negative at all. So here's a couple problems. So convert to rectangular coordinates. So that implies that this is polar. So our r is -8 and our theta is 7 pi over 4. So x is equal to r times the cosine of theta, and it is worth memorizing this because you use this a lot. So x equals -8 times the cosine of 7 pi over 4, and you recognize that as a special angle with an exact value, so that would be the square root of 2 over 2. So you're going to do -8 times that, and 2 goes into 8 4 times. So we're going to end up with -4 times the square root of 2. That will be the x coordinate. Y is r times the sine of theta. And you want to memorize that one too. So y is going to be equal to -8 times the sine of 7 pi over 4. And the sine of 7 pi over 4 is -√2 over 2. So we will have -8 times -√2 over 2, do a little canceling. So y ends up being +4 times the square root of 2. All right? And you could do a rough sketch of this point and that one and make sure that they end up in the correct quadrants or quadrant. All right, here's another one. This one doesn't have special angles. 2 comma 1.8. If that was all someone gave you with no directions at all, you really wouldn't know which system this was in. But this said to convert to rectangular, so we know that r is theta, r is 2 and theta is 1.8. So then x is going to be equal to 2 times the cosine of 1.8, and y will be 2 times the sine of 1.8. And this is automatically in radians, and we don't have any special values. So from this point on, you use the calculator, and you round to whatever place that they might ask you to do. So 2 times the cosine of 1.8 radians, that's going to be -0.454. I'll just go to 3 decimal places. And then y, 2 times the sine of 1.8, that would give you +1.948. Okay, so in rectangular coordinates, then this point is -0.454, comma 1.948, and that would be the answer. And I realized in the last one I found the x and y coordinate, but I did not write it out really the way I should. So the final answer on this one should have been -4√2, comma +4√2. That was the final answer, okay, because these are points. All right, now if you are converting the other way around, you're going from rectangular to polar. So you have x and y, and you're trying to figure out r and theta. All right, it's going to be a very similar scenario to what we were just looking at. So we know this distance here would be x, and this would be y. They form a right triangle. The hypotenuse is r. This angle is theta. So using the same old stuff for right triangles, we'll know that r squared is equal to x squared plus y squared, and we leave it this way for r squared. R could then be the positive or the negative square root of x squared plus y squared. Okay, this is the one time that we are allowing this measurement to possibly be a negative number. And then the tangent of theta is equal to y over x, and you're going to use the inverse tangent to find the angle, but it might be a reference angle. You've kind of been through that before too. You have to think about the quadrant. Okay, so some problems are actually very simple and you don't need to use a lot of formulas, at least for the angle. Okay, so convert to polar. So this is rectangular. X is -9 and y is +9. All right, now it is helpful to have a rough sketch so that you know which quadrant it's in. So this is going to be quadrant 2, so -9, +9. And when these numbers have the same absolute value, then you'll know that it's right on an angle, right in the middle of the quadrant. And so this angle is going to be a multiple of 45 degrees or pi over 4. So you really don't have to work it out. You know if it's right in the middle of quadrant 2 that you can use the angle to be in degrees, 135, or in radians, 3 pi over 4. That can be your theta. So you don't necessarily have to overcomplicate this. You can do that the tan of theta is equal to y divided by x. The tangent of theta then would be 9 divided by -9. And then if you do the inverse tangent of that, which is the inverse tangent of -1, it will give you -45 degrees or negative pi over 4. So see, this is going to be a reference angle. The calculator always gives you quadrant 1 or 4 for inverse tangent. And then you could figure this out, but it's kind of easier if you just draw it. Now the r value, r squared is equal to x squared plus y squared. So r squared equals -9 squared plus +9 squared. So that's going to be 81 plus 81, which is, you could just say 2 times 81. And then when you take the square root of that, remember, it could be positive or negative. It's really kind of your choice. In general, if you're drawing a picture and you know it's in quadrant 2, don't mess with the -1. That's the best advice. Okay, so r would be the square root of 2 times 81. And the reason I left it this way is 81 is the square of 9. So you can just see it's going to be 9 root 2. Right? If you want to do r squared equals 162, and then r is the square root of 162, obviously that will still work. Okay, so the answer I'm coming up with is to use 9 root 2 for r, and then 3 pi over 4 if I'm doing radians. Okay, so that would be one answer, right? Now, you could use the negative r value, and then you could use this angle that was the negative pi over 4 if you wanted to. So that would be an alternate answer. Okay, let's write that here. Alternate. So we saw this before. There's multiple representations for one particular point. So you could say -9 root 2, and then you could say negative pi over 4 if you wanted to. All right. In general, I think it's easier to keep r being positive and then look at the quadrant, make it fit that quadrant. Okay, here's another one that drawing a graph makes it fairly easy, because 0, -6, that's actually on an axis. All right, remember these are rectangular, so 0, -6 is right there on the y-axis. And you can pretty much look at it and know how many units this is from the pole, which is the origin, and you can get the angle, okay? So you could say 270 or 3 pi over 2. You could also do negative pi over 2, okay? Now, I'm working with a positive r, so this is 6 units away. So I could use r as 6, and then for my theta, I could use any of these, right, depending on maybe what directions that they give you. So 6, comma, 3 pi over 2, okay, or 6, comma, negative pi over 2. Those are fine. All right. It could be done with a negative r, but I don't usually try to do that. It only complicates things. Okay. Here's another one. We have 2, comma, negative 2 root 3. All right, this one we can see x is positive, y is negative. It's going to be in the 4th quadrant. All right, so roughly here. Okay. All right, so if you want to do a positive r, then make your angle also be 4 quadrant 4. Okay, so r squared equals x squared plus y squared. So that will be 4 plus 4 times 3, so that's 12. So we're going to get 16. So r squared equals 16. I'm going to go with r is 4. Okay. All right, and then to figure out what angle that is, the tangent of theta is equal to y over x. So the tangent of theta will equal negative 2 root 3 divided by 2, which turns into negative root 3. That's one of our special values. And so you can figure out that that's going to be negative 60 degrees. Or negative pi over 3. And you can do a negative angle if you like. Or you could call it 5 pi over 3. You have all these choices, okay? Any of those are quite reasonable. So I'll just go with 4, comma, 5 pi over 3. All right, but you can choose. All right, now the last one, I just picked one with random numbers. These are not special angles at all. Okay, so looking at the quadrant, x is negative, y is also negative. That's going to put us into the 3rd quadrant. All right, so somewhere over here. So what I'm going to do, I'm going to use a positive r and then a quadrant 3 angle. Okay, so r squared is equal to negative 4 squared plus negative 7 squared. So that's going to be 16 plus 49, which will be 65. Okay, so r, I'm going to use positive square root of 65. All right, and then the tangent of theta, that's y divided by x. So that would be negative 7 divided by negative 4. So the tangent of theta is equal to 7/4. Now, if I do the inverse tangent, I'm going to get some sort of a reference angle. All right, because inverse tangent doesn't do quadrant 3 angles. Okay, so if I do inverse tangent of 7 divided by 4, that's going to give me in radians 1.05. If I do that in degrees, that would give me 60.3 degrees. Okay, so 7/4 is positive, so this is giving me a quadrant 1 angle. It's up here. Okay, so I could either add or subtract 180 and have the angle in quadrant 3. Okay, and with polar coordinates, you are allowed to do either one. Okay, so 1.05, let's say I add pi to that. So roughly 4.19. If I work in degrees, I could add 180 degrees. So that would be about 240.3 degrees. Right. So one possible answer for this question then would be the square root of 65, comma, I'll write the one in radians, 4.19.